So let's do a last problem on this continuity Bernoulli and impulse momentum thing. So this mainly on a unsteady flow. So what is given is find the time taken to to empty or to decrease the height by half. Okay, so this is the tank and this is area of cross section A. The total area of cross section is capital A. This is the entire area of cross section. This is the tank. The initial height is h. What is asked is how much time will it take to increase the height by h by 2. So this is an unsteady flow problem. Okay, so how do you solve this problem? Initial height, let's say it's h naught and it's h naught by 2 is what? So how much time will it take? Okay, now this is not a straightforward problem. You can't just say that volume flow rate is just find out the velocity and then sorry. So what you do is, because the mass flow rate, there's no inlet, there's no mass flow rate inlet, okay, there's only outlet, okay, and there is the decrease in the control volume mass. Okay, so what we will do is, the other way of studying, let's say at any point of time the height is h, okay, now in the next time dt the height has decreased by dh, okay, and obviously some mass has gone out in the time dt. So the amount of mass that has gone out is how much. You can do a problem in this way or in this way. Let's say at a point of time the height is h, the decrease is dh, so the decrease in the volume of the tank is what? Area of cross section is A, dh, the decrease in the volume in that time dt is this. So decrease in the volume is decrease in the volume. So decrease in the volume of the tank is A dh, okay, in time dt, and the volume of water gone out from the jet or from this is basically velocity at the jet into area of cross section. So velocity at this point at section 2 when the height is h, so this is the volume flow rate that has gone out, okay, VA, and the decrease in the volume is this, so volume flow rate, okay, so this, so let's say the volume, let's write down in terms of volume only. So volume of water gone out is the volume flow rate area into velocity into time dt. Now ADH should be your AV dt, okay, but now what we know is that I don't know about V. V I can find out by applying Bernoulli's equation. So at 1 the pressure is P1 by rho g, velocity is V1 by 2g, plus height is at this point of time t, height is h, and outside, so at section 2 pressure is P2, velocity is V, is what I am assuming, by 2g, height is 0. This is the reference I am taking. P1 and P2 are all open to the atmosphere, and because this the area of cross section is very high, so V1 is almost 0. I can say that h is V square by 2g and V is root 2g h. So ADH is AV and V is root 2g h dt. So DH is root 2gh small a by a dt. Now this is at any point of time. Now I can just integrate this within the limits. So when time t is 0, the height h was h0. When time, I need to find time when time t when h is h0 by 2. So in that limit, this is 0 to t, this is at 0 the height is h0, this is h0 by 2. So root 2g h is 1 by root 2g. Root h integration is h minus half, it goes above, and now if you integrate it is half by half, so that is 2 root h. So this is 2 root h, this is h0, this is h0 by 2, this is a by a into t. So 1 by root 2g into 2, and this is root h0 by 2 minus root h0 is a by a into t. Okay. Now one thing I need to tell you is here is that we have just forgotten the minus sign here because this is the decrease, right? So when we are differentiating this, we are always assume that dh is increase of h, right? Increase of h, dh in all these derivatives. So I need to apply minus here because dh is already negative and minus will make it positive. So minus will come here. Okay. Okay, because dh is the decrease in h, so minus will be that. Okay, so this will be root 2g. So let's let's evaluate this. Root h naught minus root h naught by 2, that will be root 2 h naught by root 2. Yeah, so okay, the time will be a by small a, and this will be root 2 by root g, and at the inside it will be 2 h naught minus h naught by root 2. The root 2 gets cancelled, so it will be a root 2 minus 1 h naught by g. So this is the time it will take to reduce the time. So so this is the basic procedure. That's it. The at a time t, imagine the height is h. Now in time dt, the decrease is dh. So minus a dh is the decrease in volume, and the increase in how much the water has gone is av dt, and the velocity at that point. See, the velocity is not uniform. As the height is decreasing, the velocity will decrease. The velocity is just root 2 gs. So as the height is decreasing, it takes more and more time to empty the tank. That's the basic problem. So this is the time it takes from h naught to h naught by 2. Thank you.